welcome back. Professor Hank here. So today we're going to talk about classes in Java, and we're going to get a brief introduction. We're going to go over some of the terminology, and we're going to see what makes up a class and how to instantiate them. We're going to talk about what the differences between an instance and an object and all of that kind of stuff. So let's go ahead and get started. So first thing we need to know is that Java is an object-oriented programming language. That means that it's made up of these fundamental building blocks, these fundamental entities known as objects. And it is the intercommunication between these objects that controls how your program basically works. The objects are going to be responsible for storing the data and also for doing particular manipulations upon that data. So in order to have objects in your object-oriented program, you first have to have a design for those objects. And so the design for those objects is what's known as a class. And a real world analogy for this could be, imagine building a house. A house would be an example of an object, and then the blueprints for the design of that house would be the class. So you can have as many instances of a house as you want, but you only need the one blueprint. So you could build 20 houses as described by that blueprint. So you could have 20 objects as described by that class. Okay, so let's take a look at some of the keywords here that make up a class. So in a Java program, you've got what's known as a package, and the package name here is demo. And what a package is it's a container that holds or organizes or keeps together related classes. So to create a class, we have to have the class keyword, and then we have to name the class. And everything that is inside of these opening and closing brackets, they make up the class. So a class can be made up of different types of attributes. So it can have fields, or it can have methods, or a combination of the two. Okay, so methods are member functions that encapsulate or that include the logic that is needed for manipulating the object in some way. And the fields are just for storing data that object is responsible for keeping track of. Now let's take a look at this special method right here. Every Java program has to have a starting place, and that starting place is in a class, and it is inside a method that is named public static void main, and it has this parameter with an array reference, which you can name whatever you want, but it's going to be an array reference. And so this method is where everything starts. Now, if I was to create a class, what I would do is I would say class square. And class square could have fields or it could have methods. So here is an example of a field. So I might want to I need to store the length of the side of a square. So I could do something like double side. And this variable is responsible for storing the length of the side. So my class is going to be a blueprint for an object that I'm going to use to model a square. Now the methods are going to have a bunch of different pieces. First thing we'll have is a return type. So I might want to return what's inside of that variable side. So that variable side is type double. So this method needs to be able to return a double. Okay, so I'm going to name this method get side. Then I'm going to have an opening and closing bracket, and then inside these brackets is going to have all the logic that I want to have execute. So in this case, I just want to return what's inside this variable side. So I'm going to use this return keyword, and then I'm going to just return side. Okay, so that is my method, and this method is responsible for returning the contents of side. So this method here is part of the interface of my object, which is based off of this class square. Okay, now if I want to store something inside this variable side, so I'm going to have a method that returns nothing. So the void return type is what we use here. And then I'm going to name this thing set side. And inside these parentheses here, I'm going to have a parameter list that is going to have one parameter of type double, and I'm naming that parameter S. Okay, so now if I want to assign a value to this field, then what I'll do is I'll say side equals S. Okay, so right now, this class, all this is a blueprint. There is no object in memory yet. In order to instantiate this class, in order to create an instance of square, in order to create one in memory, then what I have to do is I have to go into my public static void main method, and I'm going to do something like this. I'm going to say square S equals new square. Okay, and then that, parentheses right there. Now that is going to create a new object. So new square creates a square object in memory. And the address of that object in memory will be assigned, address goes into reference S. So we're saying that this variable right here named S stores the address of a square, and that address came from this new operator, and that new operator is used to say we want a new square created in memory. Now once I've done that, I can use the dot operator to access the members of the interface of class square. So I can retrieve what's in get side, and I can update what's inside of side by using set side. So I can do something like this. I can say s.setSide and then put inside of these parentheses here the argument, say 1.7. Okay, when I do that and I compile and run this program, this method will be automatically executed. This is the entry point for a Java program. And so this will create one square in memory, which we can access through its reference. And then here I am invoking its method setSide and passing it 1.7 as an argument. That 1.7 will be copied into this variable here, this parameter variable, which then its contents will be assigned to side, which is this field right here. And since this setSide method is updating, is changing this field, this is known as a mutator because it mutates the square object. Now getSide, all it does is access something that is inside of the object and returns it. So this is a type of method that's known as an accessor. So if I want to then retrieve that 1.7 from within my main method here, I can do s.getSide, and then the contents of side will be returned back to where we called the method, and then we could assign that to a variable. So let's say something like double D. And then if we want, we can print out the contents of that D variable. So let's see that in action. Okay, so you can see there's the 1.7 right there. So what if we wanted to be able to calculate the area of that square on demand? Well, then we would just add another method to our square class. So we would do double get area, and we would simply return side times side, right? Because that's the area of a square, s squared. So whenever we call get area, then that will do the calculation and calculate what the area is by multiplying side by side. So we're dynamically calculating that. We're not storing the area in a separate field here because we don't want to risk that data getting out of date, or we don't want to have another method that's going to be responsible for updating that. We'll just calculate it on the fly. So then I can just do something like this and make sure that it's always going to be, accurate. So I'll do get area. So when I do that, we're calculating, we're just going to ask the object, hey, what's the area of the square you're representing? Well, it's 2.8899999997. Well, where did you get that from? Well, I calculated it. The area in my side is 1.7. So 1.7 times 1.7, I'll calculate that for you, and then I'll give you that number. So here it is. And then I decided that I was going to print that out on the console, right? So let's just summarize what we have here. Class square and class demo both belong to package demo. Class square has one field, and we named that side. It's type double, and it's got three methods in its interface. It's got get side, set side, get area. Set side is a mutator. Get side is an accessor, and so is get area. The public static void main method, that is used as the entry point for your program. Now, we don't have to place these in the same file. You can notice here that the name of this file here is demo.java. That matches this class name right here. Normally, you want to have one class per file. So what I'm going to do is I'm going to move this class square into a different file. So I'll just Control X that. I'll go to my projects folder, and then right here, see, there's the demo. That's in the package. I'm going to do new, and I'm going to do Java class. So then I'll put my name here, square, and then I will leave everything else alone, and I'll just hit finish. Okay, so then I'll just paste all that code back in here. Now, when you add a class to its own file, that class has to have this public keyword, public. Okay, so now if we look at our projects folder, you can see there's now two classes that are part of our demo package. So if I go back to demo.java, this is the special class that has the special method that is the entry point for our Java program. Now, classes that are all part of the same package, they all know about each other. So even though the class definition isn't within the same file as demo, this class demo knows about it because they're in the same package. They're in the same room. or they know about each other. So I can still create my new square. Okay? And we need to make sure that we have that package line up here, package demo. Right? So including this statement right here is what tells the compiler that they all go together. So now let's go ahead and compile and run this. And you'll see that we get the same output as we did before. So it's important to remember that you include the package statement in each file that contains a class that you want to be able to access each other, right? So they know about each other so long as they're in the same package, and they're in the same package if they have this statement up here, this package statement. Okay, so let's add one more class to our project, to our package. So let's do something like new Java class, and we'll call this class triangle. So I'll hit finish, and then you can see that we've got the beginnings of a new class here, and we've got that package demo statement there. So triangle, demo, and square all belong to the same package. So for class triangle, we're going to have a height and a base. So I'm going to need to have two fields. So we'll have a base and a height. And then I will include, as part of my interface here, I'll have methods for setting and getting the fields, and also for calculating the area. So we will do void set base, and we'll do double B, and then we will do base equals B, and then we will also do void set height, and we'll have double H, and then we'll do height equals H, and then we'll have a couple of accessors, three accessors. We'll do double get base, and we will return the base, and then we will have double get height, and we'll return the height. Finally, we will calculate the area. So we'll do double get area, and we will return 1/2 times base times height. Okay, so now we have a total of 3 classes in our package. So public class triangle, which has 2 fields and has 5 methods. And then we've got class square, which has got 3 methods, 1 field. And then we've got our special class demo, which is going to have just our starting method right here. Okay, so let's instantiate a copy of triangle. So we'll do triangle t equals new triangle, and then we will set its base to 1.5, its height to 2.0, and then we will print out its area. .println t.get area. Okay. So we're building up this sophisticated program here that's got multiple classes. We've got multiple objects that we've instantiated. So there's its area right there, 1.5. And each one of the classes is responsible for modeling something, right? So we've got something that represents a square. We've got something that represents a triangle. And so let's say that I wanted to take the height from my triangle T and then assign that to my square S. So I could do something like this. I could do t.set height, and I'll just get that length of the side from the square, and then I'll assign it to the height field of my triangle. So something like that. So the square, we retrieved its side dimension and then gave it to the triangle to use as its height. So that created 2 completely separate objects, right? A square and a triangle. Okay, and so once we do that, then we will print out the height value from the triangle. We'll say, okay, well, what are you holding on to? So let's check it out. It should say 1.7 now, right? Okay, and so there you can see there's the 1.7. Now there's one more thing that I want to show you in this video, and that is the access specifiers. I want to show you 2 different access specifiers. So we've got access specifiers private and public. So the scope of class square is everything that's inside of these curly braces, right? So these methods all know about this side field because they're all part of the same class. Okay, so their scope is everything within that class. Now, potential problem here is that any other object can access these things directly, and you may or may not want that to be able to happen. So side, for example, if we go back to demo.java, we could do something like this. We could say s.side equals 49. Right now, that's generally a bad idea to be able to do that. A core concept of object-oriented programming is data hiding, and that is to say that nobody outside the object should be able to directly access your stuff unless you have a very good reason. So doing s.side equals 49 could be very bad, because what if we don't want the user to be able to assign a particular value to this side? For example, does it make sense to have a negative value in the side variable? Does it make sense to have a -3 for a side, for example? If we want to prevent that, then we can add code to our set side method here to make sure that that never happens. So we could do something like this. We could say, well, if s is greater than 0, then we'll go ahead and say side equals s, right? So if we pass like a negative number, so let's go back here and we say s dot set side -33. Okay, that -33 is never going to get into the side variable. And you can see that if I print this out, system.out.println, and I do s.getSide, that value has not changed because the -33 is not greater than 0. See how it's still 1.7 here? Because if we go look at the square, when we pass -33 into the set side method, -33 is not greater than 0, so this got skipped. So we had some input validation there. We guarantee that there's no way by using the set side method that you can get a negative number into that field. Now, however, because of the fact that I can do something like this, s.side equals -33, I can bypass that method, and then it breaks my class. Because if the goal was to make sure that side could never be negative, this isn't obviously going to be a solution because look, I just changed it. So that's where these access specifiers come in. So what we can do is we can use private here. And if we add that in front of the data type, then what that's saying is you can't directly access this field anymore. So if we go back to, let's save that, go back to demo.java, take a look at s.side now. It's got a red squiggle under there saying, oh no, side, this is private. The access is private. You can't directly access it anymore. So if you try to compile the code, you're going to have problems. You're going to get a compilation error because you're not allowed to do that anymore. The only way that you can assign a value to side now is if you use that set side method. So set side -33. Okay, now you can try to do that, and it'll compile and run. But remember that -33 is going to be passed into this parameter, but since -33 is not greater than 0, it's not going to be assigned to anything. So it's just basically going to get ignored. So this is an example of data hiding. So you can see there's the 1.7. It's an example of data hiding and protecting those private fields. The only way anything gets into this side here is if it first goes through a method that's part of our public interface. Okay, now the public keyword is what you use when you explicitly want to make it so that way any object outside of the object can access it. So if we do public void set side, public get area, public get side, then we're saying anybody, anywhere at any time can access this stuff. Matter of fact, we could even make our field public if we wanted to, but we're not going to in this example. So anybody can use these methods because we explicitly made them public. Now, if I made them private, which I can do, then code outside that class or outside that object can't use it. Okay, but we want anybody to be able to use it. Now, you might be thinking to yourself, why do I have to add that public there? Set side worked just fine without it. And that's true. In this case, when you leave out either of these keywords, public or private, then the only entities that can access the methods, right? So let's say I leave this public out. The only entities that can access, the only objects that can access this method are going to be other classes that belong within the package. So without it, this is package level access. So the demo class can access set side because they're all in the same package. They're all in the same room together. Now, if there were classes that were not part of this package that wanted to use square and wanted to use its set side method, wouldn't be able to do so. The only way it would be able to do so is if we made it public. Okay, and a program can have multiple packages. And you can use these classes across packages, but you have to specify if you want classes from other packages to be able to use that set side method, you got to say public. Okay, so that's the difference between private and public. Okay, so that's everything for this video. What did we talk about? We talked about some of the fundamental pieces of a Java class. We talked about what a Java class is, what a Java object is. We talked about the nature of Java and that it's an object-oriented programming language. We showed how to make a program that had multiple classes that was going to utilize multiple objects in the program. We made a square, we made a triangle. We talked about methods, we talked about accessors and mutators, how to access them. We talked about fields and methods and what the differences are between those. And finally, we talked about the public and private access specifiers. And we also showed you how to set up a package and have multiple classes inside of a package. So as usual, if you're a student of mine, you have any questions about any of the content in this video or any of the other videos used in our class, feel free to hit me up via Canvas email or stop by my Zoom office hours. Thanks for watching, and we'll see you next time.